Hello, hello. So today we have some more notes on substitution, and we're going to look at special cases when we're substituting. So we know that when we graph, we can see the three types of answers that we can have. We either have one solution where the two lines meet at one point. We have no solutions where two lines are parallel to each other and they will never meet. Or we have infinite solutions, which is where the equations are the exact same and every x value and y value are the same for both equations. So yesterday we took notes on substitution, just how we do that algebraically, where we solve one of the equations for x or y, and then we substitute that into our equation, and we can find the other variable. So then we can find what that ordered pair would be. When x is blank, y is blank, and it works for both equations, and that would be their solution. Now there's some times where you will do your substitution method, and you'll substitute one of your equations into the other, and it will not equal an x value and a y value. So that would be when there's no solution or infinite solution. So I want to give you some examples of that so that before you do today's worksheet, if you run into that, you know what that means and how to handle that and solve for that. So this is going to be page 64 in our notes. We're going to flip to that page now. And unfortunately for you guys, this is all just handwritten. So it's just two examples. It's not going to take very long, but there isn't anything that I've printed for today. So we're going to look at two different examples. One's going to be no solution, one's going to be infinite. So if you ever see this happening to you, you'll know what it means for the system. So let's say you have two equations. That's what makes it a system. You have negative 3x minus 5y equals negative 8. And then you also have x plus 5y equals negative 1. Okay, so you got to get one of those two equations set equal to either x or to set equal to either y. Remember, you want to get one of those letters completely by itself in one of the equations so that you know what that letter equals, and then plug it into the other equation. So this bottom one, if I just move this 5y over, x will be by itself. There's nothing attached to it. There's nothing I need to divide away. That seems pretty easy to me. So I'm just going to, I'll use a different color here. I'm going to move this 5y over here. And now we have x equals negative 5y minus 1. So now I have this equation and I have this equation. And this one, x is already set equal to everything else. So I've solved for x. So what you're going to do, this was your first step, step 1. Solve for x, right? So I got one of my letters by itself. Way to go. Next, we're going to substitute this, what we know x equals, into the other equation in place of that letter, right? So if this equation has been rewritten to be this, I'm going to plug this into the first equation where the x is. If that's what x equals, then that's going to go in place of x. So I'm going to take this first equation, 3, and leave a big old space, minus 5y equals negative 8. So this is where the x was, you see? But I'm going to take what I know x is and plug it in place of the letter x. And then we just solve. So this was our second step, step 2. We substitute. We literally substitute what we solved for x in place of the x. Now, let's solve. 3 times negative 5 is negative 15. I have to bring that y down. 3 times negative 1 is negative 3. Bring down the negative 5y, the equal sign, and the negative 8. Now at this point, this term and this term are like terms. They both have a number and one y. So I can combine them. Negative 15 and negative 5 equals negative 20y. Actually, I apologize. I just realized that I wrote the problem wrong right here. This is supposed to be negative 15y. So that's going to change everything. So this is negative 15y. And this is supposed to be negative 15y. There we go. So I forgot the 1. And I also, when I rewrote my equation, I didn't bring down my negative sign. So let me go ahead and bring that down as well, which will change the signs. Negative 3 times negative 5 is positive 15. Negative 3 times negative 1 is positive 3. And then bring down the negative 15. I do apologize for that. So here we have our next line in our equation. And everything is right now. So if this positive 15y and this negative 15y are like terms and we combine them, what happens when you get positive 15 and negative 15? They cancel out, right? Positive 15y minus 15y is 0. Those completely go away, leaving us with just a 3, just an equal sign, and just a negative 8. So the question now would be, is this true? In math, is it true? Does 3 equal negative 8? No. If I have 3 of something, then the only thing that can equal is 3. A number can't equal anything but what it is itself. So 3 can't equal negative 8, which are two different numbers. They are not equal. So the question that you end up having to ask yourself, if you cancel your letters out, if you plug one letter in and you're trying to solve for the other one, and then that letter completely goes away, and you're just left with two numbers, you have to say, is it true? And it's not. So this would be an example of no solution, meaning there's no x value that you can plug in that's going to give you a y value. Like there's not going to be a way that these two equations work together. They don't have a solution. And you can see that by substitution. You don't always have to graph that. So we're going to put a big squiggle here. And then move on to the second type of example that we have, which is infinite solutions. So let's look at our original equations again. So let's say we have 3x plus 15y equals 66, and then x plus 5y equals 22. Okay, so those are our two equations. We need to get one of them. One of the equations has to have just one letter by itself. So again, I'm going to go with this second equation because I already see x is by itself. It doesn't have any number attached to it. There's no coefficient. And I think it'll be really easy to get everything on the other side except for this x because that's just one thing I have to move. So I'm going to choose this one. So again, step 1 will be solve for x. So in these examples, it's easier to solve for x. In yesterday's examples, we were solving for y. Whatever letter is easiest to get by itself. So I'm going to move this over there and get x is set equal to negative 5y plus 22. So now this is my equation and this is my equation. These are my two systems that I'm going to use. The second step, again, substitution, would be if x equals this, then I'm going to plug that into that equation in place of the variable, in place of x. If I know that that's what x is, I can replace x with that. So now we have 3, I'm going to leave a big space for x, plus 15y equals 66, right? 3x plus 15y equals 66. I'm going to put that in place of x. And then I'm going to solve. So I know I need to distribute right here and here. So 3 times negative 5y, well, 3 times negative 5 is negative 15, and bring down your y. Well, 3 times positive 22 is positive 66, right? 3 times 2 is 6. 3 times 2 is 6. Bring down the 15y, bring down the equals, and bring down the 66. Yet again, we see like terms right here and right here, except for just like before, they cancel out, right? Negative 15y plus 15y is 0. Or positive 15y minus 15y, it's 0. So they're going to cancel each other out. So the only thing we can bring down are these two numbers. 66 equals 66. So then we ask ourselves, if this is what we're getting, and all the letters canceled each other out, we're left with just numbers. There's no letters. So yesterday's notes, we would end up having x equals something or y equals something, and we would plug that back into the other equation. So we could use that to solve. If our letters completely go away and we're just left with numbers, we have to ask ourselves, is that true? Does 66 equal 66? Yes. There's literally nothing else that 66 could equal but 66. So if the number equal itself, then that would be an example of an infinite solution, meaning no matter what numbers you put in, they will work for both equations because they are the exact same thing. So that's an example of infinite solution where there's no letters anymore. They've canceled out and you're just left with a number equaling itself. Or there's no letters, they cancel out, and a number equals a whole different number, which is not true, which would be no solution. So you have a worksheet today that has some problems on it. Some of them have solutions. So you'll solve for one of your letters, plug that letter back in and solve for the other letter, and you'll get one X and one Y, and that'll be your solution. Some of them will end up having this happen to you where all the letters get canceled out and you have a number equal to a whole different number, and that's not true, so that would be no solution. And some of them will be like this, where you plug everything in, and once you've substituted and you start solving, the letters cancel and you're equal to a number set equal to the exact same number, which is true. So you have no solution, infinite solution, and one solution, and you're able to see that by substitution, which is a different way to solve systems versus graphing. So this is the algebraic way. Remember, it doesn't matter which equation you choose to set equal to X or Y. One of them has to be a letter equals everything else. You have to solve for a letter for one of them. I always like to choose the easiest one. This one has an X already by itself. It's going to be real easy to move that over and have everything solved for X. And then I can plug this into the other equation where X is. If we look at yesterday's notes, they were both already set equal to Y. So I could plug this in place of Y. There's no need to solve for X if Y has already been solved. And then same in this example. Y is already by itself. If I already know what Y equals, I can plug that in for Y. So it just depends on which letter is easier to get by itself if it's not already like that. So make sure you get all that copied down and then you'll work on today's worksheet.